Hey, um, today, wait, am I sharing screen? Am I recording? Okay, so, um, yeah, today I'm doing some contest called, this is 8:58. Let's go, let's go, let's go. Okay. In one move, she can move to diagonally adjacent point top right or adjacent point on the left if she's standing X. Oh, okay, so it's being, so it's numbered from down to top, down to top. +1, y +1 or x minus, sorry, x, y minus 1. Wait, x or adjacent point on the left. So, yeah, okay. Y-axis, x-axis makes sense. So y-axis remains the same, x minus 1. Okay. Stands on point AB and wants to find the minimum number of moves she needs to make or declare that it's impossible. Interesting. The left or diagonally top right. So first of all, if anything's below her, she can't go there. Okay. Now, if anything's above, can you always go? No. If anything's, if you're to on the complete left end, for example, and if you want to go above you, or you can go top right and then you can go left. Okay. And then from and on your own line, you can't go either. Okay. Oh, except on the right of you, I guess, because how would you go on the right if you wanted to go? Because if you do top rights, can't go left. Going left. So anything to the right of you can't go. Okay. So can you go to all of this? Or no? How would you? Okay. Let's look at samples. Oh no. I will new share desktop 2. I wonder if you can see me changing brightness while changing brightness. Way too bright. Yeah. Oh, annoying. This board has minus 10 to the 8 to 10 to the 8. We don't want to be storing this in int. I mean, you can, I guess, but I guess you can. 0 to minus 1 to 2 minus 1 to, yeah, you could do like this, like this, this, like this, like this, like this. So yes. Oh, you also need to do minimum number of moves. 1, 2, 3, 4, 5, 6. This is bad. Oh, sorry. This is minus 1. Minus 1, 0, minus 1, 1, minus 1, 2, 2, 3, 4. Yeah, this is good. 0, 0, 4, 5, 0. 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 4. So I imagine I can go to here, 2, 3, go to 4, 4. 1, 1, 2, 2, 3, 3, 4, 5, 5, and then this. So 1, 2, 3, 4, 5. Maybe this is the minimum all the time. Okay, minus 2, minus 1, 1, 1. Minus 2, minus 1. This is minus 2, 0. Minus 2, 1. Minus 1, 0, 1. 1, 1. So minus 1, 0, 0, 1. Again, 1, 2, 3, 4. Says it's not possible. Excuse me, I just showed. Oh, wait, I'm doing this wrong. I have -2, -1. This is x increases, right? So here I have -1, -1, 0, -1, 1, -1. And here y increases. So 1, 0, 1, 1. Okay. So then if I come here, it'll be -1, 0. And if I come here, it'll be 0. Yeah, it's beyond the diagonal. Yeah, I'd say that. So my claim is that for any square, all of this is achievable, right? So the minimum is go up as many and go left as many as required. And I think I can prove that that seems reasonable. And this is not possible, and all of this is not possible. Okay. So do I check this? So yeah, I think I can start coding. And so you want to check whatever's below. And if it's on this side, it means so this is the x equals y line. This is x greater than, sorry, it's x less than y, because and this part is x greater than y, right? That's how. So how do I check? So for example, for -2, -1, and then you had 1, 1. What you can do is to reach 1, you would have to add 2, right? To reach -2, if you add, I mean, for -2, if you add 2, you get 0. So this is 0, for instance, this thing. Yeah, you get 0, 1, right? So if x minus x naught is greater than y minus y naught is what I'm looking for, right? Then yeah, we don't want this condition. So x minus x naught greater than y minus y naught, or if y less than y naught. These two cases, no. Else, you will do y minus y naught, because that's how many times you go up, plus y naught minus x plus y minus x naught, because how many times you go up, plus minus x naught. Yeah. Okay. My claim. Oh shit. Why do I do comedy levels? I don't know what language I'm writing. X naught, y naught, x, y, x naught, y naught, x, y. If, what was my, x minus x naught is greater than y minus y naught, or y less than y less than y naught, C out minus 1, else C out I wonder if you could just check if the answer was positive or negative and like output. This is wrong. What am I doing? It's not y minus x naught. It is the new x, which is x naught plus y minus x. X naught plus y minus, because you're at x naught plus y right now. Then you, yeah, this is the answer. Oh, what? 4, 6, -1, 2, 2, 4. Oh, 4, 6, 2. Y minus Y naught, that's 0. 4, 6, -1, 0, 3, 3. Okay, share desktop 1. Did I take 25 minutes for this? I mean, it's not done yet, but was I like, please be right? Okay. Yeah, I remember seeing this max thing somewhere. Hmm. I see. Interesting. So, um, I might think about this for a bit and be back. Hello, I'm back. Mm, okay, let's see what we can do about this. Okay. So our best case scenario is we want 0. And I feel for even if there are less than n by 2 so the case where this is not possible is for even if there are greater than n by 2 zeros, and for odd if there are greater than n plus 1 by 2 zeros. Right. Otherwise, it's possible. Now, okay, assuming there's all these zeros, when is 1 not possible? Um, if you have zeros and all ones, because the reason being, then you're forced to get a 1. But otherwise, if you don't have all ones, what you can do is do all the zeros, do your non-1 thing, and then do all the ones, right? So that you get a, so that none of these give you 1. Okay, so this is the case where 1 is not possible. So now we're only dealing with the zeros and all ones case. What do we do here? What is the best case scenario? Here what we want to do is we know there's already greater than n by 2 or n plus 1 by 2 zeros. We want to make as many of these 1 as possible so that you at least get 2, right? Because you don't want to use up 2. And you can't get a 3. So the attempt will be to not get a 2. Yeah, that's cool. So now I'm only, oh wait, yeah. So now we already know that the max will be 0. I mean, the max will either be 2 or 3, and we're trying to make it 2, right? We know it has to be 2 because um, whatever you do, there will be a 0 next to a 1. You can't help that. If you have an arrays of zeros and ones, at some point, you'll switch between 0 and 1. So you have, so that's annoying, but you can get a 2. How do we get a 2? What we want to do for that is, and we know there's like a lot of zeros, that's the problem. The way to get a 2 is always ensure that the zeros surround the ones. And we know this is possible because we already know there's greater than n plus 1 by 2 zeros or greater than n by 2 zeros. Yeah, that's it. So you get 2. Oh my God. That's it. Let's check examples. Now, if you have 0, 0, this is the greater than n by 2 zeros case. So that's 0 not possible. Um, then you check if there exists a 1. No, if it's all zeros and all ones. And at least 1, 1. Otherwise, right? Then 1 not possible, else 1 is possible. Mm. So for example, in the 0, 0, 1 case, greater than n plus, no, so this you can get as 0, that's fine. In the last case, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 5. Yeah, greater than n by 2 zeros, so 0 not possible. And then, is it all zeros and ones? No, it's not. Then 1 is possible. Okay, that looks good to me. I feel like this is convoluted to think about. I'll be writing a knot for this, but that's okay. A friend told me to like never code up your first idea. Luckily, in my case, my first idea is usually my only idea, so. Uh-huh. Okay, it's fine. It's not that big a question also that I do some drama here. And or I don't need to do this. Just need to count the number of zeros and the number of ones. So now if I feel like I can do n plus 1 by 2 for both, right? Even if it's even, because for even numbers, n by 2 is the same as n plus 1 by 2. At least one. 1 is greater than equal to 1, and zeros plus 1s equals n. Zeros plus 1s equals n. Out 1 and else. You can always make 2 is my claim. Can do this. Okay. Okay, sharing desktop 1, choose file, .cpp, submit. We can do this. I don't even know where I check if I got this. Okay, great. Wow, 4,000 people have done this, and only 200 have done the next one. I'm gonna do the next one. Okay. So for some, and there was an announcement about this as well, so maybe I should look at that. Yeah. For some person, orders an array. It was considered as an array. Did I just read that as orders an array and think that's funny? Or was it previously orders and now it's considered? Thank God I have video evidence for all this. If you're changing questions in the middle. If this was considered and I read it as orders. Oh wow. For every subsequence of length m, the product of m elements in the subsequence is equal to the sum of the m elements not in the subsequence. Oh yeah. It doesn't matter that it's a subsequence, like a subset, yeah. So there's two MCM such subsets, right? Phi I belong to SQI is equal to sum. Define the distance between two arrays A and B, both of length K. Okay, to be, yeah, makes sense. In a positive integer n, an array P of two n integers. Yeah, I mean, the one with all zeros is always good, right? Because the product will be equal to the sum. Like twos is a good example. I feel like you'll be able to eliminate this on a case basis, it seems, because for something to be good, since everything has to work out, you should be able to like adversarially construct something. Sorry, that's not good. 10 to the 4 test cases, n is 10 to the 5, sum over n does not exceed. Okay. New share desktop 2.
What?
6, 9. Oh, probably 6, 6. The minimum guy. So then the answer would be 3. Okay. 1, 2, 2, 1. Yeah, it's all twos. All ones doesn't work. All twos. Um, so that's 2. Minus 2, minus 2, 2, 2. Oh God. You have to deal with negative signs. I hate negative signs. I wondered if this is also um Closest array to this, that's good. Sometimes examples feels like cheating almost because you get ideas from them. Okay, how do I? So two, two, two. If I did two, 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 that would be four. If I did instead, this is not good. I know that because or is this? Yeah, it's not because minus four is not equal to the sum. The answer is just the answer is five. Oh no, if I made this two and two, that would be eight. That would not be nice. How do you get five as the answer? Five, what the hell? There's an announcement. Is the announcement that the examples are like all wrong? Uh-huh. The array P is given, not A. Yeah, okay, fine. Maybe there's only like a certain number of good arrays for every size, and you just test this current array. This ordering doesn't matter against those guys. Let's say this was one. That would be three. Let's say this was. How do you make a good array from this? I feel like this example is the key to the solution. You just think of a good array of size 4. Let's say 1, 1, 0, 1. No. Okay, let's think about properties. If you have a 0, right, then you're forced, if 0 exists, full array must be 0. Why is that? Because you can take 0 and a set of a bunch of other elements, and then the rest of them. Oh no, then elements can be negative, I believe. Yeah, this is not true. All you know is pi less than 8. That's not true. Yeah, it can sum up to 0. Okay, let's try making that happen. 0, 1. We want this to sum up to this to sum up to 0. All zeros is good. 2222 is good because it's a nice number that whose sum is the same as its product. Um, oh shit. If you have, it doesn't help to have like, say 1, 2, 3, 1, 2, 3, some product. But then you could mess around and you could be like, product of this. Oh, wait, okay. So there is this property that needs to hold, which is the sum. So if you split it in any way, this sum is equal to this product. But also, this sum is equal to this product, right? So you need two sets such that the first set's product is this one's sum, and this one's sum is this product. Okay, how does that help? Um, so if I say 2, 1, the product is 2. So I make up a set with the product 2, with the sum 2. This is bad because this one's product is not this one's sum. So what does it mean to have two sets of, I mean, we're just talking two sets of numbers. Say its sum is S1 and product is P1. I see. So you need, so if you decide on a set, say 0, 1, its sum is 1 and product is 0. So you need guys with sum 0 and product 1. Which is not possible because they have to be of opposite signs if their sum 0, and they have to be of same signs if their product 1. But if you have 0 minus 1 where sum is and product is 0, then can you construct some guy with sum 0 and product minus 1? Yes, you can. Plus 1 minus 1. Sum 0, product 1. Sorry, product minus 1. Is this good? 0 minus 1 plus 1 minus 1. Okay. So if I take 0 and minus 1 together, sorry, that's already done. 0 and minus 1, that's fine. If I take 0 and 1 together, minus 1 minus 1, that doesn't work, right? I think I had this issue up. And like the same thing must hold. If it's some dumb shit, like just try all and the problem is you can't even yeah, try everything. There's 2 and CN. 2 and CN is bad, right? Yeah. Yeah, it looks bad to me. And this is such that upon any exchange, this holds. What does it mean to exchange? Okay, let's say BCD. Sum product, sum. Now this is, let's call them X, Y, Y, X. This is sum product. Say any A2, and if you are exchanging B and D, the same thing should continue to hold. So sum minus B plus D minus D plus B is the new sum. Y into D by B, X into B by D is the new product. So you need X minus B plus D is equal to X B by D. And Y minus, does this help us? Minus B plus D is equal to X B by D. Y. What am I hoping to do? This would tell me the relation between B and D, which are essentially any two elements in the array, right? Or assuming you were able to divide it into one good array or whatever. So let's get all the D's on one side and all the B's on the other. Dx minus B D plus D square equals XB. Wait, you have a more interesting thing. You have x is equal to um x into d minus b is equal to bd minus d square. X is equal to bd minus d square by d minus b is equal to d times b minus d by d minus b equal to minus d. That makes no sense. What did I do? X minus b plus d should be x times b by d. Dx minus bd plus d square equals xd. X times d minus b equals bd minus equals bd minus d square equals bd minus d square by d minus b d times b minus d by d minus b. And then I should get y equals minus b. Which makes no sense to me. Look at the array 2, 2, 2, 2. X is 4, y is 4. Exchange. Okay, yeah. Basic stuff, man. Okay, yeah. If d minus b not equal to 0, then Interesting. Pretty damn interesting. So in this case, d minus b was equal to 0. It was the same thing, right? So that doesn't hold. Um, so that gives us something that tells us that if you're able to find a good split, right? Okay, what does, think about what this means. I feel like it's getting somewhere. If this question turns out to be some fun, some binary search over all possibilities, and don't worry about this, I'm gonna kill myself. Or some nonsense like that. Shouldn't I love such cheating ideas? Plenty time remaining. Okay. Okay, what does this tell us? This tells us if you have a good split, okay, and this has some elements x and this has some elements y. I mean, so, okay, this array 1 has some elements and array 2 has some elements. Then, and when you exchange two elements, you still want it to be a good split. Then you need x to have been minus d, the element that was going to come in, and you need y to have been minus b, the element that was also going to come in. But this should be true for every single element you exchange. That means all of those elements should have the same value, right? Because x has to be minus d for all of those elements, and y should be minus b for all of those elements that come in. So that tells you that if you have a split, all the elements in A1 should be the same, and all the elements in A2 should be the same. But then I think you can argue that if you have an array, and for any split you need all of these guys to be the same and all of these guys to be the same, then the whole array should be the same. But then if the whole array should be the same, for what arrays that are all the same, the product is equal to the sum. I know 2, 2, 2, 2. That's not true for 1, 1, 1, 1. Minus 2, minus 2. That's not true. What array is Is that a fair argument to say that this means the array must have all the same elements? What I've shown is if you take the two arrays and you exchange two elements that are not equal to each other, you find no, I don't know if that means that. What does this mean? Mm, Back in a sec. Actually, I've exceeded, I think, the time I set for the question. Let me go back to problems and see if. Oh, okay. So few people have done D, but people have done E. Hmm. I feel like I have a better chance of doing this. So I will break my own rule and stay here. And I feel like this means something, but I don't understand what it means. Okay, let's think. If I do find a good split, let's just take the array of size 4. It means that if I do find a good split, and let's assume for now that no element is 0. Because otherwise this no element is 0. Okay. Then and I do feel you can prove that if there's a 0, it needs to be all zeros. But I'll keep that aside. I'm assuming. This is an assumption. Okay, why no element is 0? Because I'm claiming that sum is this, product is this. This implies that x is minus d. Okay. Have a good split. And means the sum is x, the sum is y, product is y, product is x. Then this means x equals minus d, where d is any element from here, and y equals minus b, where b is any element from here. This just means that all of these guys are the same and all of these guys are the same. This does not mean that and moreover, that the sum is of this is the negative of this, and the sum of this is the negative of any of these guys. Okay, let's see if that makes sense. So if you have minus, so but my problem lies here, right? If I make an exchange, now they're no longer the same, but it's a good split and this stuff should hold still. That means B should be equal to D, correct? Or am I making a mistake? If, okay, let's just, yeah, do this. So two numbers here, the sum is equal to minus B. And they're the same numbers. Let's say minus 1, minus 1. So their sum is 2. Their product is 1. Sum is minus 2, product is 1. So why this sum is 1? Equal to minus B. Product is minus 2. Two comma minus 1. Right? Product is minus 2, sum is 1. But these two are different elements. That's not allowed. What is wrong? Oh, this is allowed because if I exchange minus 1, it'll always be with minus 1. So this has to be D, the guys that are not in here. I see. So minus 1, 2, minus 1 is allowed. Okay, sort this minus 1, minus 1, minus 1, 2. Then this minus 2, minus 2, 2, 2. The difference is 1, 1, 3. Ah, okay, at least I got this. Is 5. Oh, I see. Either it's the same as this, or so would it be fair to say you can have only two elements? You can make up the array of only 2 elements because no. Okay, now we need a general pattern. Fair to say that all of these guys have to be the same. And then you can have okay, let's call them K, 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 K. And you can have guys here that are K or the sum S or minus S. Oh no. Okay, I feel I'm close. At least I understood this example. So what did the maths I did tell? It just said that, okay, first of all, we're assuming nothing is 0. My claim is that if anything is 0, you can show everything needs to be 0. Okay, let's prove that first. Claim if 1, 0, then all zeros. Because of negative numbers, I can't even say that. It's not easy to say. Okay, if you have 0, okay, then you have some numbers and then you have another set of numbers. If these guys are not all 0, then there's at least 2 different numbers, right? So something like x and something like minus x, blah, blah, blah. Now, if this should hold this time, 27 minutes. X and something like minus x. Now, if you take out a number and you want to put something else in its place, it has to be the exact same number. So if this is A, B, C, D, if you take out A and you put something else, if you exchange it with something else, it won't work. So this forces there to be an A. In fact, it forces everything to be all A's. If A is non-zero. But then this has to be equal to B, all the B's. This has to be equal to all the C's. And the only way that's possible is if everything is zero. Because if you have at least one non-zero, you need another non-zero. And then you need this to be equal to both those non-zero guys, which is not possible. So, okay. If you have 1, 0, all zeros, okay, this I claim is true. So then assume no zeros. If you assume no zeros, then the only issue I have in this whole calculation is exchanging the same element, right? Yeah, if the same element is exchanged, then x can be whatever, but if a different element is exchanged, it has to be minus d. Okay. So now suppose you make this and this, then I have I have a bunch of same elements here, and then I have y, the sum is minus a, and I have a bunch of elements b here, but I can also have a bunch of a's. I claim that it has to be like this. Or can it be like A, A, B, B, B? Something like this. Because if B gets exchanged with A, that's minus B. No, it can't be like this, because if A gets exchanged with B, this has to be minus. So if B comes in place of an A, no, it can't be like this. Has to be one guy with all same, and only one guy like this. So here only A can come in, and here A can come in, which is fine for anything, and B can come in, which is fine. So the array is like, so a good array looks like this. If it's not all zeros, is the claim. Now, what are these A's and B's? So for the second case, okay, yeah, where this sum equals minus B and this product equals minus A, this sum equals minus A and the product. And so for this, it was minus 1, 2, comma, minus 1. Now the question is, can you getting out of hand? Now the question is, if you fix what A is, what happens? First of all, is it possible for all A's? All A's. So let's fix it to be 1, for example. 1, 1. The product should be minus A, which doesn't work. Hey, the product here is not. How did this work? Yeah, that's fine. It works. Product here is equal to minus A, which was 1, and sum is equal to minus B, which was 2. And product equals what is it? 1 minus 1. What am I doing? Sum equals minus 2. Then here product equals sum equals 1, product equals minus 2. Okay. So first of all, you need the product to be minus A. So if you have all positive numbers, that's not going to work out because their product should be minus A. So you need all negative numbers. Is this like, oh no. Yeah, the 0, 0. So you need all negative numbers. And you need their product to be minus A, which is this. Oh no, there's literally only one option, which is the all negative ones option. Because if this were anything else, then their product wouldn't be if this were anything else, their product couldn't be minus A. So it literally can be only all ones. Okay. So in this case, for example, x equals minus 4 and y equals 1. Now you need 4 guys. And this has to be like an even number. And now you need 4 guys whose sum is 1. And product is minus 4. So then that's 4 minus 1 minus 1 minus 1. Oh my god, is this like the only option? So you just need to test these two arrays. So you test the all zeros array. And the all, so in case it's if divisible by 4, you test the all minus ones and n by 2 array. So you just test these two, whichever is smaller you output. Okay, let's see. Let's test it for this test case. -3, -2, -1, 0. 2, -1, 0. 1, 2, 3, 4. If I do the all zeros array, I'm gonna get 3 plus 2 plus 1, and then 1 plus 2 plus 3 plus 4. 10 plus 6. 6 plus 10 equals 16. If I do this array, -1, -1, -1, -1, -1, -1, 1, 4, then I'll get 2 plus 1 plus 0 plus 1 plus 2 plus 3 plus 4. 3 plus 1, 4 plus 4, 8 plus 5, 13. Oh my god, okay. You need to be calm and slowly code it up. C.cpp. Int and cnn. We have plenty of time. Oh, they'll give you n, and then it's an array of size 2n. Or int I equals 0, I less than n, I plus plus c in a of I sort a dot begin a dot n. Oh, it is the magnitude. So LLF equals 0, comma S equals 0. In plus plus F plus is equal to abs of A of I 2 into S plus is equal to abs of n minus 1 I plus s of a of I minus 1 s plus equals a of 2 into n minus of 2 into n minus n. Oh, I need to check for if it's divisible by 4. If n mod 2 equals 0, see out min of f comma l l 0. Copy. What's slash a dot o copy gpp c dot cpp c dot out 4 1 oh where the hell did I oh okay. Minus 15 6 5 13. Oh yeah, there's plenty time. I guess in the case of 2 if it's 1 1 half of A of 0 minus A of 1, right? The reason being copy 3, 6, 5, 13. Why did I get 6 for this? Is this also a special case? Yeah, 2 is also a special case. If no. If it's 2, you also need to check with all 2s. That's the thing, okay. Not this. 'N equals 2. Out minimum of minimum of F, F, 3, 2, 5, 13. Choose file. Oh my god, it passed. Phew, that was 1.5 minutes left. But yeah, quite a few people did it by now. 3 master. Yeah, I don't know. I'm not gonna do this, but that was good. I hope it actually passed everything. Okay, this is done. Okay, it feels so good. I don't know how. Okay, still not the best, but it's not too bad either. I mean, that was so nail biting though at the end. Uh, Conditioned on it actually gets accepted, but still. All right, see you guys. Bye.